In this video, you will learn an important part of the syllabus that belongs to Chapter 1 Mechanics. Lesson 2 Forces. We will see some examples on how to draw force diagrams to find the resultant force using the parallelogram method. This car is being pulled by two trucks. The blue-colored truck pulls with a force of 8,000 newtons. The white truck pulls with 11,500 newtons. The two forces are not in line. There's an angle of 45 degrees between the two forces. To find the resultant force of these two forces using parallelogram method, you will need number 1 a pencil, number 2 a ruler, number 3 a protractor, number 4 a compass. The first step to draw the force diagram is to choose a suitable scale that can fit your exam paper. Finding a suitable scale. The first scale we normally think about is 1 centimeter to 1 newton. In our case, this means that you need to draw the 8,000 newton force as a line of 8,000 centimeters length. Sure, this is impossible. So let's find a bigger scale, 1 centimeters to 10 newtons. This scale means that the 8,000 newton will be represented by an 800 centimeter line. This is also impossible on an A4 paper. The bigger scale is 1 centimeter to 100 newtons, and the same force will be an 80 centimeter line, which also is unsuitable. Choosing a scale of 1 centimeter to 1000 newton will make the 8000 newton a line of 8 centimeters long. This can be easily drawn on a normal paper. So our chosen scale will be 1 centimeter to 1000 newton. Now we need a reference to start our force diagram from. It will be easier to take our starting force, the vertical 11,500 newtons. According to our scale, this is represented by an arrow that is 11.5 centimeters. So get the ruler, and using your sharp pencil, draw a vertical arrow that is 11.5 centimeter long. After that, get your protractor and put its center point exactly on the start point of the arrow you just drawn. Mark the angle of 45 degrees on the protractor. Get the ruler again and draw an 8 centimeters arrow. This represents the second force, which is 8,000 newtons. Here comes the time of the compass. To complete our parallelogram, open the compass to just fit the length of one of your forces. Let's start with the 8 centimeters. Move your compass to the shown position on the head of the other force and draw a small arc. Now open the compass to just fit the length of the 11.5 centimeters arrow. Move the compass to the shown position and draw another arc. Note that the two small arcs intersect in a point. This point is the close of the parallelogram. The diagonal of the parallelogram you got is your resultant force. To find its magnitude, just measure its length using a ruler. This ruler shows that the diagonal is 18 centimeters. Do not forget the scale. This means that the force is 18,000 newtons. Also, we need the direction. We will find the direction using the protractor. Find the angle with the reference force, which was the vertical 11,500 newtons. In this case, the protractor shows that the diagonal is making an angle of 18 degrees with the vertical force. Magnitude. The resultant unbalanced force equals 18,000 newtons. The direction. It's making an angle of 18 degrees with the vertical force to the southeast. Another example that describes a big rock that is pulled by two boys. One pulls with 66 newtons and the other pulls with 132 newtons. There is an angle of 70 degrees separating the two forces. Find the resultant unbalanced force on the rock by the two boys. Just as you did before, you need to find a scale that is suitable for a normal paper. As usual, we start thinking about 1 to 1. 1 centimeter to 1 Newton. This means that the forces will be represented with arrows 132 centimeters and 66 centimeters. This is impossible to draw on a normal size paper, so we will find a bigger scale, 1 centimeter, to represent 10 newtons. This makes the arrows of 13.2 and 6.6 centimeters long. These are suitable lengths and this will be our scale. Our reference line that we will choose to start our force diagram will be the horizontal force 132 newtons. Bring the ruler and using your sharp pencil draw a line of 13.2 centimeters long. Now use your protractor to measure the angle, which is 70 degrees. Now again, get the ruler and draw the second force represented by 6.6 centimeters, keeping the 70 degrees angle between the two arrows. Now the compass comes. Open the compass just to fit the 6.6 centimeters arrow. Move the compass to the other end of the 13.2 centimeter line, as shown, and draw a small arc. Now open the compass so it exactly fits the 13.2 centimeters line. And do the same and draw another small arc. The two arcs intersect in the point that closes the parallelogram. Now draw the diagonal of the resulted parallelogram and measure its length using the ruler. The ruler shows that the length is 16.7 centimeters, which means that the resultant force is 167 newtons. Remember that the suitable scale you choose is 1 centimeter to 10 newtons. Do not forget to find the direction of the resultant force by measuring its angle with your reference force, the horizontal force. The protractor shows the angle is 21 degrees, so we can say that magnitude, the resultant unbalanced force equals 167 newtons. Direction, it is making an angle of 21 degrees with the horizontal force to the northwest. A third example shows a small toy that is hanged as shown. This causes unequal tensions in the two strings. The angle between the vertical line and each of the two forces are 54 degrees and 31 degrees. The magnitude of the two tension forces in the string are 8.6 and 13.5 newtons. Find the resultant unbalanced force of the tensions in the string. Let's start with finding the scale. The small values of the two forces give us a chance to directly use the simplest scale 1 to 1, 1 centimeter, to represent 1 newton. Now we need a reference to start our force diagram from. Unfortunately, none of the two forces is vertical nor horizontal, so we will not start with any one of them as before. We will draw the vertical dotted line and this will be our reference. Now to draw the 8.6 Newton. Use your protractor first to measure the angle of 54 degrees. Get the ruler and now draw an 8.6 centimeter line representing the 8.6 Newton tension force, respecting the angle of 54 degrees. Again, get the protractor and find the angle of 31 degrees on the other side of the vertical reference line. Now you will draw a line that is 13.5 centimeter to represent the 13.5 Newton. This 13.5 centimeter line is with an angle 31 degrees with the vertical line. Now we need to close the parallelogram. So get the compass. Open the compass to fit the first force 8.6 centimeters. As you learned before, move the compass to the other end of the other force and make a small arc. Now open the compass to exactly fit the 13.5 centimeter force. Draw the arc by repeating the same thing. The intersection between the two arcs is the point that closes the parallelogram. Complete the parallelogram and draw the diagonal. This represents the resultant force. Now use your ruler to measure the length of the diagonal force. The ruler shows it's 16.6 centimeters long. According to the scale we have, which is 1 to 1, this means that the resultant force is 16.6 newtons. No need to measure the angles because our force here is clearly upwards. Magnitude 16.6 newtons. Direction upwards.